Hey folks, we can get started here. Can somebody, I hate to have to do it this way, can somebody just give me a thumbs up in chat and let me know that you can see the whole screen? YouTube Studio's, I think, having some sort of rendering issue on my computer. It's probably some travesty that I committed in butchering my own browser, and it's probably my fault, but yeah, if somebody can just confirm that the scene is good, you should see my text editor on the left, a section of my browser on the right, and then my camera below that. So let me just actually adjust this. I meant to get that centered. Symmetry, yes, that's better. Cool. All right. Let me just get a few things. Okay, cool. These keep getting rearranged. All right, that's good. All right, so today, a little bit different than what we usually do. I'm going to go over the weekly challenges that Remy Arata posted on Monday. So if you look up in the basic prep Slack channel, you should see a few days ago, you should see that Remy posted those questions. I think basically everybody's aware of those at this point, but yeah, we're going to start doing this. Remy or somebody will post the questions on Monday, and we'll give you a week to solve them on your own without spoilers, and then I'll do solutions either in stream, or I may record a separate solution to videos depending on what feels right. So let's just start going through these. So here's the first one, and I'm gonna approach all these sort of with like a mocking up a workflow that I would do, or at least as best I can. So the way I like to do things: copy my problem statement, pop it in my text editor so I can chop it up and kind of make it make sense in the way that works for me. So remember, anytime you're trying to understand a new function or a problem statement for a function that you're going to write, we want to look for input, process, output. And this is not the only, this is a simple rubric that I was taught a long time ago. Process, processo? Process? Okay, there we go. A simple rubric that I was taught a long time ago. There are others, somebody's saying like input, process, education, or input, inputs, edge cases, processes, outputs. You could add to this, but this is a basic schema. A lot of times you can tell what a function is supposed to do just by looking at its inputs and outputs if that's listed, right? And you kind of need that for a complete problem statement in most cases. Cool, so we have these examples here. I see that. I'm just going to turn these into tests. Before even reading the problem statement, I know I'm going to need some tests. At least that's the way I like to work. Oops. There we go. There we go. All right. So there's some tests. It looks like this is the name of the function I'm going to be writing. Just clear this out a little bit. Oops, needed that line. Def this. We'll just pass for now. Just do a little bit of a sanity check. Make sure these print none. This is our red stage in red-green refactor. Oops. Right. That's what we expect, though, because I forgot to give it the arguments. Okay, cool. So now let's actually read through this and see what it's asking us to do. So complete the function called quad solver. This function should take in 4 parameters, a, b, c, and x, where, and I'm going to make a nice little bulleted list where each of these lines sort of looks similar so I can reference them easily if I need to. So a is the coefficient for the squared term. B is the coefficient for the x term. C is added on at the end. And x, just delete this and. Function taking in 4 parameters and x, okay. X is the value for the x terms. Okay, cool. So this just is a quick note on my inputs, and it's a nice little visual reference. So if I need to reference one of these at some point, I can just come back, and they're nice and organized. So I like to do that. I always suggest that. It's a good, just helps you keep organized. So and it doesn't have to look exactly like mine, however you do it, but I just recommend putting some effort, whatever's going to work for you in terms of organizing your problem statement, can really help sort of grease the wheels. I don't know. There's a phrase there or something. Okay, so quad solver should return. So now I'm looking for my output. So these are my inputs. Remember, input, process, output. There's my input, and here's my output. Return the result of the quadratic function with those values. If you're unfamiliar with the quadratic function, you can learn more about it here. Obviously, here is a link, which we'll go to here. Cool. So here's if we look in the challenge, there's just a link to the Wikipedia article on the quadratic function. If you're not familiar with it, you can kind of read through here and get an idea of what it does. I'm not going to dive way in depth into this or do any proofs or anything. But it's basically just this part, right? Actually, I don't know. Is that going to show up if I make that selection? It's probably not going to show up on OBS. It's not showing up. That's okay. I have a little screen highlighter tool, but it's not being captured by OBS. Okay. So it's, let's see, it's this part, that part. So this may, whether you're really familiar with this or not, it'll probably sound familiar, at least to most of us. Ax squared plus bx plus c. And that's the section that we want to implement. So we have a, x, b, and c, a, b, c, and x right there. So ax squared plus bx plus c. Okay. Okay, cool. So we got to take in these parameters. Let's do a, b, c, x. Just run that real quick, make sure everything's kosher, my tests are failing properly. Should just be seeing 1, 2, 3, 4, 5 nones. That looks good. Cool. All right. So now we'll just implement that formula. Ax squared plus bx plus c. So we can just return that, and I'm going to use lots of parentheses. I'm a fan of just using, if you ever have the thought like, well, how do I know what order this is going to execute in? Just put in the order with the parentheses rather than counting on the order of operations to handle it for you. That's honestly my opinion. It's not like a, ultimate Pythonic truth, or if you don't do this, you're not doing it right or whatever. But it is my preference, and I do notice that if you kind of follow that rule of not being afraid of parentheses, that it's easier to kind of learn how to translate math expressions into code. Okay, so let's just do this. So a x squared is a times x squared, x squared. So there's our first term, and then plus bx, and that's b times x. And then this term plus c. Cool. So if I run this, I should get 86, 7, 49, 56, and 1. Let's see what I get. The interpreter is just getting slower and slower. Okay, so I get 86, 7, 49, 56, and 1. I expect 86, 7, 49, 56, and 1. Good. Looks like it's passing. So let's come over to learn. And oops, you didn't see that. Good. That's working. Cool. All right. On to the next one. And if anybody has any questions about any of these, you don't have to wait for me necessarily to get to it. I want to, this is still an open dialogue format. So if you have any questions at any point, don't feel free to jump in. I want to make study halls as much of a dialogue process as possible. So it's an opportunity for you all to ask questions, and for me to strategically ignore those questions. I mean, take those questions. I'm just playing around. Okay. Oops. The lag on my computer. I feel like OBS, which is the streaming software, the screen compositing software that I use, used it on Linux, and it's like real nice and smooth, and then on Mac it's like all my resources are just devoted to OBS. So I did mention this last time also, but I'm getting a new computer, and I know that a number of people recently have brought it to my attention. The streaming quality is low, and that's actually deliberate, unfortunately, because I reduced the resolution settings in order to have a higher stability of the stream. So it might be a little bit low. I think it's at 360p right now, but that should be improving in the coming days or weeks, depending on when my new computer gets here. Okay, cool. So mult table. So what are we taking in? In, it looks like, and I'll just put in a pass. So now I have this nice little structure. Now I'll read my problem statement. Okay, so write a function called mult table that takes a single number, r. Oops, that looks like a typo. It takes a single number and returns a list of lists that represent a multiplication table of that size. So an example of size 3 multiplication table would look like this. Okay, cool. So, Just had a minor distraction there. Okay. So for this one, I've had a couple people ask me about this since Monday. This is an interesting one. My take on this is a twist. This is a simple problem with a little bit of a twist, kind of. Hopefully I can make that clear. So we want to return this table. I'm just going to call it a list. Actually, no, I'm going to call it a table. So table or matrix or something, I like to give it a name that's going to remind me something about what it is and its structure. So a table to me says a list of lists. So we'll start with this table. And from here, I can just write a pretty vanilla accumulator pattern. We got our table, which is our accumulator target, and I'll say for I in range. And I want it to be n wide, so I'll say 1 to n plus 1. Right? I could just say n, but I actually see what I want to be doing is literally building a multiplication table by multiplying the numbers starting at 1 through up to and including n. So instead of just doing range n here, I'll start the range at 1 and go to n plus 1 so that I get the right number of iterations. Cool. And then, so this is one thing I can do. So I can think about this like every time I get a number out of this range for each new value of I actually just, quite literally want to run some very similar code. We'll call this J. There's a convention if you're going to have a nested for loop and your outer loop, the identifier in your outer loop is called I, to call the identifier in your inner loop to call that J. And if you have another one, you call that K. So H, I, J, K, etc. It's not often that you have a triple nested loop. It's not even, well, I guess occasionally you'll have a double nested, but not that often that you'll have a triple nested loop. So I'll just follow convention here just so it's nice and straightforward. So think about it like this. If I print I times j, for those of you who have solved this, you may be noticing I'm skipping a little something, but we're just trying to like model the way of thinking through this, right? So if I print I times j, and let's just isolate this down to one test. We'll do this test with 3 in it. Get a multiplication table of 3. And this table should have 1, 2, 3, 2, 4, 6, 3, 6, 9. And this process will produce 1, 2, 3, 2, 4, 6, 3, 6, 9. So this actually gives me all the right numbers, and now all I have to do is just put them in lists 3 at a time and then put those lists in the table, right? So I can think about these as rows. So I need a place to put each row. So I want to put this in a row. So I can say row dot append, right? And I better create something called row, otherwise it's going to give me an error. So we'll say row equals a list. So here's the trick. The question is, and I mean, I gave it away, but you know, where does row go? You might want to put it up here, and let's try this out. So if I append this to row, and then the question is, where do I append row to table? Oh, excuse me, table. And let's just play around with these positions a little bit. Okay, so this does give me a list with all the correct elements, but they are not grouped in the proper list, and they're just way too many lists, and they're all the same. So this isn't quite right, but it's a table of things multiplied together, kinda, right? So the cool thing is, a lot of times you can kind of guess your way to a solution. So we can adjust this left and right. So if this is going to append row every single time this inner loop runs, right? So if n is 3, we're going to have for I in range 1 to 3, and for j in range 1 to 3. So it's going to go 1, 2, 3, and then advance to the next one for I, and then j is going to be 1, 2, 3 again, and advance the next one for I, and then 1, 2, 3 again. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 total iterations. And I'm going to be appending row to table every single time, so therefore I get 9 identical lists. And they're identical because at no point did I reset row, right? And we'll get to that in a second, but see if you haven't solved this yet, or if you have, see if you can infer what I mean by that. We need to reset row at some point so it doesn't just keep growing. But we can play with this and just kind of move this around. This interpreter is slow. Okay, well, this is still not quite right, but this does have a list of 3 lists, so this is a step in the right direction. Remember what I said about resetting row? So I want row to start as an empty list every time I start a new looping through this range for j, right? So what I can do actually is just move row down, kind of make that a little more obvious. I'm using shortcut keys to like pull this this line around, but to move that line with my cursor. So I can put row in here, and now every time we advance the value for I, we're going to set row equal to an empty list. And we don't even need to initialize it up of here, because this is the initialization and the resetting of the row list. Cool. So if I run this, someday, cool, 1, 2, 3, 2, 4, 6, 3, 6, 9, and that's what I expect. So let's just run our other tests and verify that that's actually going to work. And here's a fun bonus. This problem can be converted into a comprehension. Now, quick disclaimer, comprehensions are awesome. I'm not going to discourage anybody from learning comprehensions. However, depending on your level of comfort with Python at this point, I will say comprehensions aren't strictly necessary. They're actually a subset of for loops, and what I mean by that is the problems that a comprehension can solve can also be solved by for loops, at least in terms of the algorithm, right? The process of solving them. Comprehensions have the potential to be more optimized for the problems that they can solve. So they have a potential to have a take use of like parallelization in your CPU, so for multi-threading, so things like that. Python can kind of make optimizations behind the scenes. That being said, a lot of times those optimizations aren't really that important. A lot of times the way you make something run faster in the real world is to run it on a bigger, more powerful computer. And I'm not going to knock code optimization. I actually really enjoy it. It's a part of computer science and programming that like just really fascinates me. But I don't want people to think that if they're not writing comprehensions, that they're not programming. You will encounter that attitude. I've seen this in various places on Reddit, and not that all of Reddit is like that, but on Code Wars, I've seen this a little bit, where people are saying, well, you're not doing it right unless you're using comprehensions instead of for loops, or you should always write comprehensions instead of for loops. And I really don't believe that, and I don't think you should hold yourself to that. Especially if you're just learning, just stick with for loops. That's fine. If you're writing working code, then nobody really has the right to criticize you that much, unless you're doing something where optimization really is central. So if you're just learning, stick with for loops. That's fine, and you'll learn comprehensions when the time is right. Okay, cool. Rant complete. So how do we turn this into a comprehension? So what I like to do is this sort of thing where I take the list. So we're doing list comprehensions. We get a list out of a comprehension, and we take the thing we append. So I crack open the list, and I'll take the thing that I append, wherever the append is, and I'll put that first, and then I'll put the for loop inside after that. We can't quite do that in this case. There's a little bit of an extra step that we have to take. So let's walk through this. So I'll look at this append, and I'll realize, okay, I'm appending row. What is row? Well, row is another list. So I actually, in order to append row, because I can't just stick this for loop inside of the comprehension like it is. It has to be syntax that works with the comprehension. So the appends and the traditional for loops kind of have to be rewritten. So we also have to rewrite row as a comprehension. So in order to place row in table appropriately, it itself has to be a comprehension. So let's do this one first. And I want you to notice, you'll hear me say this, and this is another one of those times. You'll hear me talk about like working from working backwards, like from the destination to the beginning or whatever. Like this is kind of one of those times where you sort of work your way in so that you can work your way back out, right? So we're working our way back out. So we start in the innermost append. We'll break that open, and we'll put that first in the new comprehension for row. And then we'll just clean up the append there. We don't need that anymore. And we'll take the loop head and put that after the thing that we appended, right? So that's one thing. Okay, and we'll cinch that up. Okay, so this should work on its own because I have for I in range 1 to n plus 1, and then I'm turning row into a comprehension and then appending that row. So let's just try that. I should get the same result eventually. I'm going to move on because it's taking so long. Since I'm saving this in row and then immediately using row and only using row once, I don't even need to set row as a variable. I can just append that directly, right? And now, thankfully, this is my new append value, right? So that's nice for converting this other loop into a comprehension. So let's crack that open. And we'll crack open this append. And we'll take this. This will be the thing that we're appending. So this goes first. And we'll take the loop head and clean up the append that we don't need anymore. And delete that colon. And put that there. Okay, cool. So again, this should work. But notice, same sort of thing. I'm saving this into table and then immediately returning table. And I don't need to I just don't need to set table as a variable. I can just return this directly. So this problem can actually be solved in one line. This is my previous solution. Cool. So let's try this. Here, actually, let me get back to the original for loop solution that I had. And I want to juxtapose these against each other and kind of talk about that for a second. Okay. Okay. So I'll comment out that one, and we'll just run the other one, what you call it, the comprehension. So we can see that works as well. And just for the sake of consistency, we'll comment out the comprehension and run the procedural version, and that'll work as well. Cool. Okay, so let's juxtapose these against each other real quick. Both these are fine solutions. I'm not going to say, I just want to make it clear, if you're able to do the for loop solution but not the comprehension solution, you'll get there. Just keep doing for loops for now. If you're able to do the comprehension solution, then that's awesome. What I don't hold myself or anyone else to is to do the comprehension solution first. And people will disagree with me about this, and that's fine. I mean, there are different reasons to have other opinions about this that make sense. So this is not the gold standard of everything that should be considered canonically Python. But in terms of my experience, just like wanting to produce working code quickly and optimizing that code sort of efficiently, I go for this kind of solution first. I go for the straightforward, simple, vanilla for loop solution. I'll just hammer this out, and you can get to the point where you can just do this real quick and then look at this and be like, oh, well, I can turn that into a comprehension pretty quick, and it's not that hard to turn it into a comprehension. Whereas it can be weird to write this as a one-off for your first solution. Maybe less so in this particular case. This is not that complicated of a comprehension, but it's getting to the point where, if there was much more complexity to this particular problem, this comprehension could get pretty nasty. This could turn into a monster easily if there was much more complexity. And you can kind of see that it is starting to sort of turn into a monster. It's already starting to become like it's a long, dense line of code, So, if you can hash that out the first time, just type it out like you're typing a sentence. That's great. If not, don't worry about it. This is fine as your second solution. The rule of thumb that I would say with comprehensions is, if you have a for loop, try turning it into a comprehension. If you look at it, and have the thought like, if I worked with somebody who insisted on writing code like this all the time, would I want to strangle that person? Would it be infuriating, right? In this case, this is not that bad of a comprehension, but comprehensions can get pretty nasty and confusing pretty quickly. And if you look at that and you think, would I want to work with somebody who wrote code like that? If the answer is no, then you can just leave it as a for loop. It's probably not that big of a deal unless you're really up against an optimization problem where every CPU tick counts, which those problems do exist. So, all right, I've made my plug. Comprehensions are awesome. Optimization is awesome, but it's not the gold standard. It's not the only thing you must know. For loops are fine. They get the job done. All right. Looks like we got a question here. When returning the table output, do the lists need to be stacked like a table? You mean, it sounds like visually. The my first solution to this was I totally went off the rails, or not the first solution, but I wanted to print it off so it was like nice and pretty, and it was actually kind of in a square matrix when it printed out. So I did write a version of this. Actually, let me see if I can find that. I think I have it archived here. Sorry. The answer to the question is, in order to pass the tests, it doesn't need to be stacked as such. Visually stacked. The interpreter doesn't make a distinction between whether the lists are stacked on top of each other or they're just in a list. Like it just is the list that contains the elements that it's looking for. So when I say it doesn't make a distinction, I mean it doesn't have it's not that it can't tell the difference. It's that it doesn't have the ability to produce a difference, if that makes sense. There isn't the ability for a difference to be had in the first place in terms of the value of the list. So hopefully this will, let me actually try to find this really quick. Yeah, okay. So here's a couple solutions I had to this where I did, I just wanted it to be printed out in a pretty way. I'll put these down here. Actually, I should comment these out so we don't get them confused because there's kind of a lot. Okay, so here's my initial sort of procedural solution with that. I have this fill parameter here, which is going to give me the length of the string of whatever n is squared, right? So the largest number in the matrix is going to be n squared, because if we have 3, we have 3 at the bottom of the column and 3 at the right of the top row. 3 times 3 is 9. So I turn that into a string and then get the length of that string, and this is for formatting. I'm doing this for formatting, not for the problem solving. And then for this, I'm doing for column top in, I should have just called this I and J, but I kind of gave these different names that I regret. But this is I, column top is I, and then same thing with row, and then row left is J. Same ranges. And I had these broken out as variables, but I decided to do it in one line as well. So I'm appending the string of I times J, and then since it's a string, I'm calling write justify with a width of fill, which is the character size of the largest number that we could produce. So if it produces a 4-digit number, all of the elements are going to be pasted in as strings with 4 spaces on their left hand side, and the number is actually going to be justified to the right. rjust is right-hand justify. It's a string operation. Okay, and then once that's done, this was table. I called it matrix, table.append, blah, blah, blah. And these are comprehension versions of that. And then to print it out pretty, I did this. And let's just isolate this down so we know what we're looking at here. Okay. So this is my test. This is my test. So I had a whole thing here just because I was just like, I must see it. Someday it'll run. Okay. So notice how everything is print, and I didn't print past the squares because I just wanted it to be that way. And that sort of formatting is done in here. And I'm saying, so for limit and row in enumerate, mult table, 10. I'm using limit. Oof. I'll just do this for now, because limit is just sort of something else I was just playing around. So we'll just pay attention to row here. Well, I guess I can butcher this code because it's not like I still have the other copy. Row. So we'll just do for row. Oops. Yeah, that's a much simpler test. The lengths I go to see properly formatted. Oops, nope, I broke it. Okay, whatever. Okay, at any rate, I don't need to step through this whole test, but yeah, this was what I did to like print off the whole thing in a formatted way. But it's hopefully you see like the links that I went to are that I actually changed the type that I'm producing here, right? I'm rather than producing a list of numbers, I'm producing a list of lists of strings of right-hand justified numbers. So yeah. So when you think about, and I wanted to give this question some airtime because when you think about how things are laid out visually to you, it's not it's important to make a distinction between what is formatting to you and what is a meaningful difference in the value to Python. And it's also important to like format things in a way that makes sense to you, obviously, so you can see it better, So this was a lot of fun, just playing around. I solved a problem and I was like, well, I don't know, maybe I just want to make it prettier, so I was just playing around and doing this because I had nothing else to do, so why not? So this lays it out visually in a way that I liked, but it changed the value, so in order to get that visual, it changed the value, so at least the way I did it. And then if you want to see a monstrous comprehension version of this, these comprehensions are, yeah, I did turn this into a comprehension. I have a couple different versions of it, actually. So this is the one-liner of the visually formatted multi-table. Now this I look at, and I don't know, I mean, I'm not going to discourage you from writing this as something like this as for fun. I would write this for fun. Optimization isn't a need for me, so I don't need to do this. I think I look at this and I laugh and I'm like, yeah, if I imagine, if you worked with somebody that wrote code like this that was like comprehensions are the only way. You know, this is quite the line. There's a lot going on here, and you can parse through it. You can go through and understand it, but I think this is easier to read. So if I did have to write a comprehension like this, fortunately, there are some formatting options that you can use to make it sort of break things out and make it more readable. And perhaps this is only something that I think about because I'm dyslexic, and it, you know, like it really helps me to kind of, you know, break things out onto multiple lines. So this doesn't look too bad. These two are exactly the same, except the lower one is just formatted. It just has things broken out, and I even took some notes. So this bracket is the list for my matrix, and then this inner one is the list for my row. So I could go through here and kind of parse this by eye and pick it apart line by line a lot easier. And that might be, you know, so you do have options if you find yourself needing to write or wanting to write a really long, nasty comprehension. You can break it out and sort of space things out in a visually pleasing way. It's not enforced though, so the formatting is all visual. You know, so I could do something dumb like this, and I think that's going to work. Actually, might not work. I don't think that'll work. No, that works. That totally works. You know, so you have to be careful. The formatting, you know, it can get off and it can get inconsistent. And if it gets inconsistent, then, you know, a bad attempt at good formatting is potentially worse than no formatting at all. So, you know, if you do format things like this, there's no indentation checking, and Python, you know, we're used to Python, we're kind of holding our hand with enforcing good formatting because the interpreter needs that. And it's not only useful for the interpreter, but it makes nice readable code for us. But if you do format a comprehension this way, it's all on you. Be consistent or write a for loop. So there's that. Okay, that was quite the rabbit hole. Cool. This is a great question. I appreciate a question like this because, yeah, I like to, yeah, like I said, I want to give some airtime to that. Like, what's the difference between the value and how I see the value? And that can be, you can get a lot of understanding out of that kind of question. So, thanks for asking. Cool. Okay, one left. This is an interesting one. It's a fun one. I like it. Anyways, I suppose I should frame it as my opinion because that's what it is. Apologies, the sun is setting. Let me go turn my light on here real quick. It's getting a little dark in here, so I just wanted to shed a little light. Okay, cool. So here's our next one. And let's grab these examples, turn them into tests. Not even reading the problem statement yet. I mean, I have read all these and done them, but yeah, we'll pretend like I'm not even reading them. I mean, this is the first thing that I do. Anyways. Oops, okay. Do that. Aha. There's that. Space. Okay. Bingo. Okay. I think I'll do this and just clean this up a little bit. Okay. So this is a pretty interesting problem. Okay, so there are a class of problems in computer science that deal with items coming out of a queue. A great example is a self-checkout line at the grocery store, where one line of shoppers wait to check out at multiple registers. So for this example, imagine that everyone can only check out one item per second. And I would say, or some other arbitrary unit of time. Sorry. Okay. So write a program that's called queue time. Okay, so queue time will calculate, and I'll say and return the time it takes, and we'll say time, sort of time or complexity, the time it takes for a given queue to be processed by some number of processors. So the processors will be like, if you can think of a self-checkout line, the number of stations where a shopper can check out. Okay, cool. So I'm just thinking about ways to kind of lay this out. Oops. Okay. Queue time. Let's do this. Def queue time. I don't know what we're taking in yet. Pass. So it returns the time of the given queue to be processed by a given number of processors. So the function will have two parameters. So the first one, called queue, will contain integers that represent a task with its value being how long it will take to complete. The second one is called processors. Okay. So queue will be you can think about queue as a list of shoppers, and the value of each shopper is the number of items they have in their cart. Okay, so this is saying list of integers being the number of items in each shopper's cart that represent a task with, I didn't write this. Yeah, that's, I may need to go back and do some copy editing on that. Or perhaps it's very obvious and I just need to reread it until it makes more sense. But I know the integers will represent the number of items in each shopper's cart. Okay. And then processors will represent the number of processors or checkout stations to work on the queue. So let's think about this a little bit. So first, let's put in our queue and processors, and let's kind of look at one of these examples. This seems like an interesting one. So let's kind of step through this. And when something is well, you know, when you have a kind of a larger, more complicated problem, if the answer isn't necessarily obvious right away, it's good to just like break things out. And you can do this by hand. I prefer to do this out of my text editor. Personally, you can do this by hand, but go trace the code, step through it, imagine the loop in your head, right? So we'll have, I'm going to call this cart sizes list, because that's what it is, right? This is a list of people's cart sizes, or, you know, cart number of elements in cart list, but size kind of captures that. Okay, and then let's call this checkout stations. Checkout stations equal to. Okay, so here's a little trick. Imagine we had a way of representing the we want to go through each of these carts and treat them as a time. Each of these carts is a time that it will take for a given processor to complete checking those out, right? So if we had a way of representing in processors starting at 0, in this case just 2, if we had a way of representing in processors, and we'll just bake in 2 for now, we could add these numbers to the given processor, and that would show how long it's taken each processor to complete up to that point as we loop through this list, right? So in this case, and let's do this. Let's say stations, let's call it stations list, and we'll just make this a list. So we don't need to like name them or anything. I mean, they have indices. We can refer to each one specifically. So, okay, thinking about this problem, we've got 3 people in line. The first person in line has 3 items in their cart. So both of these stations are open. How would I say this? They both have spent 0 time processing people's carts. So I guess these are the first 3 people at the store or something. So this person has a choice of which to go to. So if there's ever a choice, if there's ever like one option is as good as the other, we're just going to go for the leftmost one. So, you know, the leftmost one is closer or something, so that's the one they're going to go for. So we'll add their items, their time, which is 3, to this. And this other person also has a choice. Well, they don't have a choice because the other person took the first one. So the first 2 people go to both processors and like this, right? Okay, so now we know it's going to take this stations list sub-0 processor. It's the name of that processor, station 0. It's going to take that station t times 3, time, whatever your unit of time times 3. So let's say 3 minutes or 3 seconds to process this first person. And it's going to take this second one 7 seconds. So and there's an answer to this, where does this person go? Imagine you're the person with 5 items in your cart. The person on the left took 3 minutes, and the person on the right is going to take 7 minutes. Which one are you going to choose? And based on what criteria? I mean, the criteria is that the station, whichever station is open when you're up in line, right? You go to that station. And I want to give you all a second to think about this. So you're the person with 5 items in their cart. One person's going to take 3 minutes to check out. The other person's going to take 7 minutes to check out. Well, the person who took 3 minutes to check out checked out before the person who took 7 minutes. So you go to station 0, which is this. And then we add your items, 5 to the 3, which will be 8. We can say 3 plus 5 is 8, right? So, all right, so that concludes our going through items. So the question is, what's the answer to our problem? Or maybe it's the problem is what's the answer to our question? The answer is this is a system that has a time defined by the station that took the longest to complete, right? So you check out 4 of your items as this person checks out their last item, and then that queue is, or that station is now empty, having spent 7 minutes being active, and this station, you check out 1 more item, and this station takes 8 minutes to complete. So the answer is whatever, the final result is whatever max stations list is. Okay, so we can think about it that way. And we can even do, well, yeah, I was going to say we could do this again just to solidify this. And let's actually do that. But since I know max stations list, I need to return that. This is the final answer, right? So let's just do that. Let's say return. This is the same thing I was talking about before, like anytime anything is just given to you, you might as well just write it down. Okay, so we'll do this. And let's walk through another problem just to kind of solidify this again. So let's say, and I'll just copy these actually. So we'll have 2 checkout stations again, and we'll do different numbers. We'll have 3, 5, 2, and 9. Okay. So again, and I kind of left this hanging last time, but we have an empty list, and notice I just created an empty list here. We wanted empty buckets for as many stations as we have. So how do we create that? Right now I have an empty list. You know, I can bake in as many values into the list as I need. Just, you know, I can sit here and do this. But how can I get Python to do this dynamically for me based on this number, which is really called processors here? So what I can do is that the initial state here is going to be a list with 0 concatenated against itself as many times as processors, right? Which is going to give me, if processors is 8, it's going to give me a list with 8 zeros in it. Cool. Okay, so we got that sorted. So we only have 2 here. So we'll just do 0, 0. Whoops. And okay, so same thing. So we have a person with 3 items in their cart. Their choices are 0 or 0. Both of these are free. So they can go to this one. Second person, well, this other one is free, so they'll go to that one. Third person, where does the third person go? Well, by the time the first person, or station 0 person is done checking out, station 1 person is still checking out, so they need to go to station 0. So 3 plus 2 is 5. And we have basically the same scenario we had when these were 0. These are equal, so the next person gets to choose. But if they have a choice, if there's anything that's up to choice, they're just going to go for the leftmost one. And they'll do 9 plus 5 is 14. And then we're done. We're done going through people in the queue. And then in this case, the max, the final result is whatever station took the longest. Cool. So the question here is, how do we determine, again, and we kind of asked this, how do we determine that? Think about that. So at any given point, the next person in line, so we're 3 and 5 went, we're on 2 here. The next person in line goes to the station with the lowest number. So 2 goes to station with lowest number. Cool. Okay. Hopefully, hopefully that's enough. Hopefully that'll do. All right, so let's actually start modeling this in Python. So again, we'll start with going through the people in the cart sizes list, which is called Q here. So we'll say for, what should I call this? Cart, I'm going to call this cart size in Q. For cart size in Q, I'm going to call this stations list. I'm going to take my stations list, and I want the person with this cart in the queue to go to the queue with the smallest number. So to go to the station with the smallest number. So min station list is going to give me the station with the smallest number, but it's going to give me the value. And I actually want to use indexing to say which station. So I'll say stations list dot index of whatever the min of stations list is. Okay, so we're going to go to the station at the station and stations list at the index of stations list with the value of whatever the smallest value of stations list is. So we get that value, we get the index of where that value exists, and we go to that in stations list. Okay, so now that we're there, we want to add what to it? We want to say plus equals the time taken by the person with this cart, which is the value of that cart size. Plus equals cart size. We'll run through that. Once all that's done, we'll have a list of stations where each value represents an amount of time taken in aggregate for each of those stations, and we don't want to return the whole list, we just want to return the one that took the longest, because that tells us what our total time for this system is. So let's see, I'm going to run it. We should get 15, 8, 10, and 22. Eventually, someday. 15, 8, 10, and 22. Bingo. Cool. I thought this one was a lot of fun. This whole stations list, substations list dot index of min stations list is a real zinger. It'll get you. Cool. So let's submit that. Cool. There's my code. I had a different version in there before. Didn't really need to hide it, but I don't know, just felt right. I like this version better. I was secretly ashamed of the other one, but I wouldn't admit it. Cool. And if we look through the suggestion, it's pretty similar to what I did, just kind of different names. So. Awesome. All right, well, those are the weekly challenges. Let us know. Feel free to reach out to me and let me know what your thoughts are for the weekly challenges. If you have any good ideas we're open to, if you have a problem from somewhere that you want to point us at that you think would be a good weekly challenge, or something that you were working on or something. Yeah, let us know what you think of them, if you found them fun and helpful. We're open to your feedback. Cool. We do have some more time left in study hall, but this is also a natural breaking point. Yeah. So I'm not seeing any questions. If anybody has anything that they'd like to go over, I think I'll just give a second for that. And we can come through and do learn material next week, if folks are into that. Cool. Well, this seems like a good breaking point. We're ending a little bit early. Generally, we'll be continuing stream till, what is it, 4:30 Pacific time? 5:30, I'm in Mountain time, so 5:30 Mountain. But yeah, feel free to reach out. If you're on YouTube, give us of course you're on YouTube. If you're watching this on the only place where it's watchable, then give us a thumbs up, like, comment, subscribe if you feel moved to do so, or give us a thumbs down if you hated it. Send me a mean DM if you don't like my face or something. Be nice about it. I don't know. I'm open to feedback though, for real. If there's a way that you think I can improve study hall, I'm going to be putting a lot of energy into getting these to be as good as they can be over the next few weeks. Resolution issue included, that will be improving as well. So yeah, don't be a stranger. DM me on Slack if you're not on Slack. We have links in the description to where you can go join the Galvanize prep, premium prep or basic prep. It's free to join basic prep, and you can come on and DM me as you like. But yeah, we'll wrap up there. It's been a pleasure. You'll have a great rest of your evening. Bye-bye.